Now we are proceeding with the third panel. The third panel of the European Blockchain Week is dedicated to artificial intelligence and renewable energy. Blockchain technology and artificial intelligence are contributing to significant changes in various industry sectors and our society. There are already many use cases in the market that address energy production and energy efficiency. Still, the next 5 years will be crucial due to spread of physical network development. The moderator of this panel is Ioannis Vlachos, Director of EMEA Energy Web and also member of EUBOF. Ioannis, the stage is yours.
Thank you for the kind introduction, and I'm really excited to have our distinguished panelists here. So without any further ado, let's set the scene for this discussion. So the topic of this panel is blockchain and artificial intelligence for renewable energy. So what we're trying to achieve in this panel session is to take a closer look at the way that innovative technologies such as blockchain and artificial intelligence can promote and foster the energy transition, and especially the way these technologies support the increase of the penetration and use of renewable energy. So today on the panel, we have some great speakers with us: Sabine Brink, blockchain lead at Shell; Gregor Novak, CEO of Sun Contract; Kai Schmid, innovation manager at Elia Group; and last but not least, Arjen Zuiderduin, project lead Flex and at Stedin. So Arjen, I hope I pronounced your surname correctly. I will not try to do it twice, though. So let me start with a short introduction about the profiles of each one of our guests. So Sabine is the blockchain lead at Shell. This global team is tasked with navigating the waters of blockchain technology and to realize the potential of the applications across Shell and the energy sector. Prior to this leading role, Sabine was also the blockchain technical lead, looking after architecture and development of decentralized solutions. And before that, she had the role of a blockchain analyst. Over the years, Sabine has led and advised the development of a range of blockchain proof of concept pilot projects and worked with multiple external ecosystems. So Sabine holds a master's degree in information and network economics from Maastricht University. So Sabine, welcome. Kai Schmid from the Elia Group holds a master's degree in energy economics and business administration after joining Elia Group International as a consultant in the field of asset management and power system operations. Kai became an innovation manager at Elia Group, focusing mainly on future energy markets. As part of his role, Kai has set up a DLT lab, distributed ledger technology laboratory within Elia Group to test and validate DLT technologies in relation to the integration of distributed assets. Along with industry partners and leading blockchain companies, the DLT lab of Elia develops new approaches to tackle the challenges of a future energy grid. Now, Arjen is a proud father since 1.5 months ago of his baby girl, Evie. Besides being a full-time dad, Arjen works as innovation advisor at the Dutch DSO Stedin. Arjen works on several practical implementations of smart grids and blockchain solutions, one of which is the one focusing on decentralized identifiers of both DSO and prosumer assets. The projects Arjen is working on are contributing towards a transition from the network operator to system operator. So it's a new and exciting way of interacting with prosumers for the Dutch DSO. And last but not least, Gregor Novak, which is the co-owner of Sonce Group and CEO of Sun Contract. Gregor is an accomplished executive with nearly 2 decades of experience in the power industry. And before the establishment of the Sonce Group, he worked in 2 of the most important national energy companies in Slovenia. As head of informatics, he participated in the establishment of the company Borzen. Later, he took over the role of director of the ICT department at Eles. And more than 10 years ago, he and his partners founded the Sonce Group, which deals mainly with investments in renewable energy sources and construction of solar power plants. In 2018, as director with an international team, he established the first peer-to-peer energy marketplace based on blockchain technology smart contract, which enables direct trading with electricity between producers and electricity consumers. So many thanks to all of you for accepting our invitation to participate in this panel. And let me kick off our panel session by setting the scene of our discussion and sharing the screen with you. So my name is Yannis Vlachos. I am the commercial director for Europe, Middle East, and Africa with Energy Web. And what we're going to discuss today is the way blockchain technologies and AI can promote and foster the energy transition. So at Energy Web, we're focusing on the blockchain aspect of the energy transition. And just to give you a brief overview, what we are focusing upon. So we all know that today's grid is shifting from its traditional grid architecture towards a more decentralized, consumer-driven, consumer-centric architecture, where we have a lot of distributed energy resources spread across the grid, and we move away from this, let's say, structure of the grid where the utility was supplying in a one-way energy to the consumer. So we have now multiple flows from energy coming from the utility, from the prosumers as well. So this transition from the traditional grid to the new one asks for new tools in order to meet the challenges and barriers. Also, an interesting finding that was recently also supported by an extensive study carried out by Bloomberg is the fact that currently it seems like consumers are investing more in energy related assets than traditional utilities. And when we're talking about energy assets, you can count in electric vehicles, residential storage, smart thermostat, smart plugs, and so on. Collectively, it is expected that by 2030, consumers will invest more than traditional utilities invest in distribution automation equipment. So this transition is what made, let's say, Energy Web to set up a decentralized architecture, and Energy Web was founded back in 2017 in order to provide to grid operators with an open source decentralized architecture in order to meet and address the challenges that are introduced by this energy system architecture. So the mission of the Energy Web is mainly to develop and deploy a decentralized digital operating system for the energy sector to support the energy transition towards a low carbon energy future. So to date, we have assembled an ecosystem of more than 100 market participants. You can recognize the logos of some big names in here, Shell being one of them, Vodafone, EDF, E.ON, Elia, and so on. So what we're doing with our ecosystem members is working together with them and helping them to use the open source technology that we are building in order to solve the problems that they face in day-to-day business. So in terms of infrastructure, what Energy Web is providing is this so-called decentralized operating system, which is, at least from our perspective, the missing digital infrastructure layer in order to connect energy assets, that is the bottom layer in this figure, with energy market, which is the upper level that you see here. So in order to tackle this, we have developed a blockchain-based decentralized set of SDKs, software development kits, that can be used freely by anyone to develop solutions that can leverage the trust imposed by the energy web chain, also leverage the services provided by our utility layer services like messaging services, decentralized storage, decentralized identities, key recovery mechanisms, and so on, in order to build their own toolkits with the ultimate goal of connecting in a seamless, trusted, and cost-efficient manner energy assets to energy markets. So our motto is any energy customer into any and any energy asset into any energy market, and this is what we are trying to achieve together with our members and affiliates. So what we believe is the core component in this energy transition towards a decentralized grid is the concept of a decentralized self-sovereign identity. So what we have here is the digital passport of an asset. So this digital passport is owned by the asset itself, is managed by the asset itself, and once this asset has been pre-qualified by the respective authority, being the TSO or the DSO, then it can be trusted by any market participant. We strongly believe as Energy Web that the use in a pan-European scale or in a global scale, if you would like, of self-sovereign digital identities is the way forward in order to enable small-scale energy assets, small-scale distributed energy resources to participate directly into energy markets without the need of any intermediary. And this is what we show here in this diagram, that any asset being, let's say, for example, a residential battery or an EV or a PV inverter or a customer or a building itself, to own its own identity, and through this identity to authenticate itself to several applications, and then get authorization by these applications to participate in different markets. So I think the role of blockchain technology combined with the tools that the artificial intelligence carries in its arsenal is probably the most efficient way to move forward a more decentralized in a more decentralized architecture of the grid, and for creating tools to meet the challenges and overcome the barriers that this decentralized grid today has. So thank you all for your attention, and I will now stop sharing and give the floor to Sabine Brink from Cell. That it is very interesting to see how a big corporate like Shell sees technologies such as blockchain, artificial intelligence being part of their day-to-day business. So Sabine, once more, thank you for accepting our invitation to participate in our panel today. And without further ado, the floor is yours. Thank you.
Great, thank you so much. And just testing, you can hear me, right? If I get a bit of a nod, yes, perfect. Right, everyone, good day. And first of all, thank you so much for the invitation to come and speak here and to share a little bit about the work that we're doing at Shell, but also why, for example, I really believe that emerging digital technologies like blockchain will have a fundamental impact really on the energy transition that we have at hand. So thanks so much for the introduction. Like mentioned, my name is Sabine Brink. I lead Shell's global blockchain team, and we sit in a larger organization which looks at all new digital emerging technologies that is globally spread, and we really focus on creating new innovations and new technologies for the future of energy. I've been fortunate enough to be able to work in the blockchain team for about 4 or 5 years, and that's really been since the inception that the team started. So it's been so much fun to start to work from the get-go in, when the days when Bitcoin and Ethereum all came out into the industry, and really trying to think about, hey, what is this fundamental technology going to have an impact on the energy industry at large? Throughout this journey, it's been an exciting one, I can tell you, and I hope today I'll be able to share with you a little bit more about how we see this tech, where I see the key opportunities are for us in the energy industry, and also some of the key projects that we have been running and the capability that we've been building. First of all, maybe to start off with on a bit of a higher level, right? I think if we look at the energy industry at large today, I think we can all safely say that there is amazing urgency for us to decarbonize. And in order to do so, we need to fundamentally re-architect, I believe, the energy industry or the energy system. If you look at exactly what has been shared on the slides before, traditionally, we've been very good as an industry at producing energy in a centralized manner and distributing that to consumers and to industries. But that whole picture is fundamentally changing, where we're seeing, first of all, the development of distributed energy resources entering this grid, all playing a part of this energy system. But also the fact that it's not just about giving energy access, which is very important across the world. We also need to provide a sustainability offerings and low carbon energy across the world, and we need to decarbonize our energy system. Now, in order to do that, I think one of the key things to realize is that that's not overnight a simple task. I think it was already illustrated, our IT systems in the energy industry need rigorous change. There's complexity in data that is today captured in silos by companies, organizations, or markets even, that it's very hard to communicate with and across energy industries. And there's many partners involved in complex supply chains, and by producing energy and consuming it and making sure the grid is a balance, making sure we have low carbon attributes flowing through our energy system. So all of this, I think, in order to transition to a modern day architecture, a modern day grid where we can accelerate the transition to net zero, but we need to use all the new emerging digital technologies available to us to really redesign and really bring innovative solutions to the market. That, to me, makes it extremely exciting to work in this space, because we have, on the one hand, this energy industry that is changing, it's transforming, it's has loads of innovation ongoing, and at the same time, we have these new emerging technologies, especially blockchain, which has such a fundamental impact on the way that enterprises, consumers, people can interact and transact with one another. So that's why I believe the conversion of, first of all, this interesting industry, but also this super fundamental technology has a lot of for us at play and a lot of opportunities for us to make a difference. I think, what we're sometimes have a tough job at doing, or what people sometimes forget, is they get caught up in the whole innovation of blockchain in isolation. And I think one of the key things for us to realize here is that it's not just about blockchain in isolation. But we believe at Shell that it is really that combination of different emerging technologies that come together that really converge into these new innovations that can help us decarbonize, but also help us to create new technologies for low carbon futures. Let's zoom in then a little bit on why blockchain and why we've got this core capability. So just to give a bit of a demonstration before I do that, within Shell, digitalization has been a key priority for us for years. It's very high on the strategic agenda. We have about, I think now it might even be outdated, but more than 350 people worldwide working on things like data science, AI, high performance computing, blockchain, robotics, all across the world. And these capabilities work together really to bring out these new solutions, which makes it really interesting. And I have the fortunate job to be able to lead the capability of blockchain. And to be honest, this is a well-established team now for 5 years that has really been tasked to build capability across Shell. I have a very clear strategy on how we execute blockchain projects across the energy industry, and to make sure that we build new solutions and create partnerships with companies and networks to accelerate this movement. For us, I see 3 key areas in this strategy. First of all, what is extremely important for us, and when you see blockchain with any new type of technology, one of the first natural things that you do with this fundamental change is look at existing processes that we have in our industry today. And the existing processes in the energy industry, I can tell you, they are bound for some innovation and bound for some efficiencies to be gained across that group. For example, supply chains. This is for us a key area where we say, hey, we work with so many different partners across the supply chain. There's so much information exchange happening. And a lot of these processes or a lot of digital innovation has often happened between silos of companies. What we're actually proposing and what we're actually working on in a number of pilots across the group is to say, let's create that level playing field in the industry where we can automate transactions across the industry as a whole. We can create supply chain efficiency and supply chain automation by the use of, for example, digital passports for equipment and material traceability. We've implemented this across the group, and that's accelerating at quite a pace to collaborate on an industry scale to get this implemented. Now, the second strategy pillar that we as a team work on, and we've risen to quite a high strategic agendas in Michelle, is it's not about just looking at existing processes in the energy industry. To demonstrate, to really go to decarbonizing the energy future as a whole, we need to take a step back and look at complete value chains. And this is really exciting to me with blockchain, is that you see value chains really converging in one another, where we've got energy markets like, for example, hydrogen, or the electricity market, renewables, that is going through extreme transformation at the moment. And at the same time, you have this technology like blockchain, which is fundamental in creating transparency, creating efficiency, and creating really that traceability in these value chains. So think about energy, for example, think about carbon, think about mobility. All of those types of areas converged into one another and have links. Now we're working here to really create new value propositions towards our customers. For example, in how do you trace the origin of energy and how do you prove the attributes of energy towards customers, so creating more transparency in the energy that you produce. And for example, what I think is going to be super interesting in future as well, if you imagine the convergence between the energy industry, mobility, EVs, charging, decentralized identifiers that enable these kind of markets to converge to a much more interesting level. And lastly, our last strategic pillar, which is one that personally really excites me, is all about looking further into the future. I think, traditionally, if we obviously compare a lot of times to the internet, blockchain with the internet, in, let's say, the 1994 era, I don't think many people really realized what the true fundamental impact of internet was going to be to our lives. That today we'll be able to track an order to our front door by the minute. We will be able to communicate with friends so easily across the world, or buy anything at the tip of your fingers. Well, to me, I think, in a couple of years' time, we're going to be seeing those extreme, really innovative blockchain solutions that in the energy industry are making things happen that we can't do today. And that's why our innovation teams are working with many different ecosystems across the energy industry and startups to really come together and see how do we create these kind of new markets, what kind of interesting solutions can we bring to the market to make sure we transition and decarbonize as soon as possible. So for the rest, I'll leave it here for today. I think my time is almost up. For the rest of the panel, really look forward to sharing more of the projects that we've been working on and deep diving into some of these specific areas. So thanks, and head it back to you.
Thanks, Sabine. Thanks a lot for providing us the insights on how Shell perceives innovative technologies into their day-to-day business. So our second presentation for our panel today will be delivered by Gregor Novak. Gregor is going to present us Sun Contract and the way that blockchain technologies can help develop an innovative and self-sufficient energy marketplace that supports peer-to-peer energy trading. So Gregor, it is a pleasure having you with us today, and the floor is yours. Thank you.
It's my pleasure to be in the conference. It's nice to be here and talking about energy, talking about blockchain and AI. We are all on this. So regarding the Sun contract, we started with Sun contract on the market in 2018. So we did first introduced on the worldwide on the blockchain, and it was also founded, supported by the blockchain community in ICO in 2017, and in 2018 we actually opened the market. First peer-to-peer energy market on the, let's say, national level. So what problems do we solve? First of all, we wanted to do peer-to-peer energy marketplace where the retail users are involved directly. So this was actually our goal to do this, because up to now it was not possible. The second one, we know that everything is related to utilities, still it is. We think that if we wait utilities to renovate, to do transition to green energy, we will be cooked here in this planet. So that's why I think we have to be active as users and not waiting just utilities. They are very welcome to support, and they do, but we have to be active as well. So Sun contract actually enabled that everybody can participate in this game, this energy game, and to support transition to come to full 100% to renewables. So in this regard, we did, this is still not implemented yet, but it's going to be very soon, that everybody who is participating in some contract, everybody who is consuming or producing renewable energy can connect even borderless. It means borderless peer-to-peer energy trading. So this nobody has implemented yet. I think Sun contract will be first. And third one, we know that the climate mitigation we are facing here. And of course, because we are enabling customers, we already do this last 3 years. So we are not talking about the theory. We are here very actual. And we do this project with real customers on the national level. So we also help to mitigate the climate crisis which is here. And because we are pushing and enabling customers, they are investing in solar, they're investing in wind and hydro, and so they are investing in renewables, and then they connect to the marketplace and they can manage their energy by themselves. So these are actually the 3 points, the problems we are solving. Of course, base here is blockchain that would bring trust to those customers. And of course, we are supporting renewable energies only. So we implemented this in the national level, I said 3 years ago, and our aim is to do it also borderless around Europe and worldwide, wherever the market is at least a little bit liberalized. So I think we have plenty of countries, whole European Union and many other countries where we can implement right now. And in future, I think will be even more. So this is our platform, which is running with real customers, and people can, on this platform, can decide the price. They can set the price. So we are not intermediate in this case, and the payments are going directly from one to another on blockchain, on crypto tokens, on SNC tokens, which our main token alone. So this is totally liberalized and decentralized and democratized marketplace. So we can, I listed here a few services we do. Of course, we do peer-to-peer energy marketplace. This is our base. We enable also personal deals in case that somebody knows other, and let's say in family bring some energy from father who has a solar power plant to daughter somewhere around the country. They can bring energy, or to neighbor or whatever. So they can move energy by themselves. This is also possible within existing legislation in European Union. So this is actually, because people said it's not possible, it's not legal, whatever. Yeah, we got a lot of inspection, I can tell you. and all inspections we passed. It was legally confirmed, and now we are verified, I can say. In also, it was mostly from the energy and financial sector. So those we got a lot. So we do, of course, energy monitoring, which is the, let's say, product itself. We show what the energy status from our customers. Where the net metering is enabled, like in Slovenia, we also enable, of course, energy surpluses. If the customers have surpluses regarding the consumption side, they can, of course, manage those surpluses by themselves. They can move it to another calendar year or to other person, or now with the new Renewable Act, it was supported, I mean, accepted here in Slovenia in August. They can even sell this energy right now. Before it was not allowed, but now it's allowed as well. So, of course, we do. We support all renewable energy producers and sources. They can be connected to our platform, and they are. And we enable all this trading from renewables. And of course, from the beginning, we actually started just with crypto. So energy consumers, they bought energy just with crypto in the beginning, but later on, we enabled also, of course, the fiat currency. So now about 80% people are buying energy with fiat, and then this fiat is then transferred to crypto and everything going on blockchain. The rest, they're actually going directly with crypto, and they're buying or selling energy directly with crypto. So we enable both from most of the time. Okay, these are just some few numbers regarding our traction. Just in Slovenia, Slovenia is not a big country, 2 million population, but still you can see these numbers here, and the growth is about 100% per year. But of course, when you open another countries, this will be much bigger. We are in energy sector. So phase one, I can say, was completed. 3 years here is verified. We have a mature solution, which is on the market, confirmed from the market, confirmed from the regulations, and with a cash positive burn rate. Now we are in the process until the end of the year to prepare our platform for 1 million users, and of course to set global new energy services. I cannot tell you more about today, but I can tell you that it will be very known this year. We will introduce these new services, I can say revolutionary services, in December 12th in Dubai on the World Expo, where we will release all this data about our new services and about new markets we are planning to do. So I can maybe tell you that we are very proud. 2 days ago, we got award from the biggest Slovenian energy community or experts. They choose Sonce and Sun Contract in combination, actually, for the best Slovenian renewable energy and energy efficient project for this year. So we are very proud of this, and we see that also we get support also from the energy field as well from the customers. So this was from my very short introduction. If you want to contact me, you can contact me, and we are very happy to have some partners in other countries to extend these services for around Europe. And I think it's very good for us, for you, and for the nature we care about. Thank you very much.
Thank you, Gregor, for your nice presentation. To be honest, a little bit jealous seeing you there in person. I was also planning to travel to Ljubljana, but yeah, COVID didn't, let's say, allow to make this happen. So we have seen corporates, we have seen startups, transmission system operators play also a key and sensitive role, especially when it comes to stable operation of the power grid. So we are excited to have today with us Kai Schmidt, which is the innovation manager at the Elia Group. And Kai will provide us an overview of the current challenges of the energy system from the perspective of a transmission system operator. And Kai will also present how Elia Group leverages the concept of decentralized identifiers to do asset identification, as well as to set up and realize several other different use cases. So Kai, welcome, and the floor is yours. Thank you.
Thank you, Johannes. Thanks for the warm welcome. Good afternoon, everyone. I'm very happy to be here on the conference, and I'm happy to share some insights of my and our work at Ilya Group. So as you already mentioned, I'm leading the DLT lab. So it's a lab where we look into blockchain technology. We try to identify the potential use cases, test it and validate it. And my presentation today will give you a short introduction of who we are as Ilya Group, what what we think will be the future power system, so where the challenges lie, and then how blockchain can give an answer to that, provide a very important building block. It's not the only one, and this is also why I think it's important that we talk about other technologies here. And I also, try to embed blockchain into other emerging technologies. So who we are a transmission system operator. So we operate the high voltage power lines that you see along the highway. We cover Belgium as Ilya and 50 Hertz in Germany, in the eastern part of Germany and Hamburg. So in our grid area, we supply 13 million end customers with electricity. We run nearly 20,000 kilometers of high voltage line. And our tasks are basically planning, building, maintaining the grid and substations. That's one part. Other part is balance the grid. So we are responsible for keeping the grid frequency at 50 Hertz. So we have flexibility market mechanisms that allow us to balance it and to ensure that the lights are always on. And we also contribute to market development. So we, especially in this time right now, we see that energy market is changing due to many things that have already been said, but mostly due to the renewable integration, due to a higher decentralized energy system, many more players that enter the market. So we also further develop energy market mechanisms, and we also have a consumer-centric market design that we're working on, where we put the consumer in the center. And why is this the case? It's the case because we see that the energy system is moving from a very centered to larger power plants energy system, where the energy flow is going from nuclear power plants, coal power plants toward end customer. So from the higher voltage level to the lower voltage level with no flexibility. So this was the past, and what we see in the next decades is that this completely changes. So you see nuclear phase out, you see coal phase out, and you see that generation units, rooftop solar PVs are installed on private households. We have distributed renewable energies, we have offshore energy, and that builds a very complex system. That system contains many stakeholders, many market participants, many assets, and it's integrated not only in a country, but it's integrated in the continent. So we also have cross-border interaction, and it's also not only the energy sector that we're moving in, because new products, new developments are cross-sectoral. So we speak especially about sector coupling with e-mobility. So e-mobilities are basically batteries on wheels that we can use for grid operation. And we have to make this accessible. But that means also that we have to take care of customer needs. We have to align and coordinate with many stakeholders. So DSOs, with us, with energy suppliers, with energy market operators, and so on. So this whole system is becoming very complex. It's becoming very dynamic, and there's an uncertainty that we have to deal with. So renewable energies cannot be planned like coal and nuclear power plants. So they produce energy when wind is there and when the sun is shining. And we have to adapt towards this. That means create flexibility on the consumption side, move towards a system where consumption follows the generation, and also do everything to really get flexibility in that system. And how do we react on these emerging technologies that you need? So we have an innovation hub where I'm leading the DLT lab, but we also have other centers of excellence like AI, IoT, augmented reality, virtual reality. We have an internal incubator where we can develop new projects and new ideas. And I think many tools where we support this. We have a very strong data strategy. It's one of our tier 1 projects. We want to become a digital TSO. and that is all interlinked with each other. But today it's about blockchain and AI. So blockchain, I don't think that I have to go into details of the technology, but at the end, there are maybe 6 things that the technology allows. So it can be used as a static registry. More important is, for me, identity management. So we can give assets, entities, people an identity that they own by themselves. So we don't need an intermediary to do that. We can embed smart contracts, so automated contracts that are embedded in the code. It allows for dynamic registry, so not only for cryptocurrencies, but that can also be used for green certificates, and this is also what we looked at and what we're doing. Payment infrastructure, so micropayments for peer-to-peer trading, for electric vehicle charging processes, you name it. And another very important point is the verifiable data. So independent validation of information is something that is new and was not possible in that way without blockchain technology. And I think in that system where we have so many stakeholders, this is of high importance. And this is also what I'm doing in plenty of projects. So we look into e-mobility because this is right now the fastest growing source of flexibility. And there are many use cases, as I already mentioned. These batteries are of high value for the energy sector. So we look into products like green charging. How can we prove that the charge energy is fully green? We look into new services where you can choose your supplier at a charging station, or you can even use the energy that you produce at home, your rooftop PV panel at public charging station. We look into how can we make flexibility available. So can we steer the charging process, use that for self-consumption at home, and look into settlement and billing processes. But it's only one piece of the puzzle. And I think it's probably a combination of blockchain for decentralized identification to create trust. But then we need also data that comes from IoT devices. Then we need data management systems, and we need artificial intelligence to process this data and to help us to react faster and better to new changing situations. And I think this is the field where we're moving. So it's not only technology, it always has to do with market and regulations. So only if that adapts to new needs, we can also use the full potential of the technology. So technology, communication, and market and regulation layer is very important. And that's it for me. Happy to discuss everything else, dive into details of our projects in the following discussion. Thanks.
Thanks a lot, Kai, for presenting your insights as a TSO into the topics of blockchain and AI. Now, last but not least, Arjen from Stedin will provide us with a bird's eye view of the way that this time distribution system operators see these innovative technologies. Also having the views of a DSO on the way that these innovative technologies help the digital transformation is of great importance, since the vast majority of the consumer assets that are providing the flexibility that Kai mentioned in his presentation are connected to the distribution grid. So Arjen, welcome and thank you for joining us today. Looking forward to your presentation.
Thank you, Jannis. Am I okay for the crowd to hear?
Perfect. We hear you perfect.
Thank you. And thank you for having myself and Stedin at the European Blockchain Week. We love to be here and present our bird's eye view indeed on the projects we do, the vision we have, and the way we move forward. Yeah, so about Stedin, good to know that we are the third biggest DSO in the Netherlands. This is our operating area, providing the 3 major cities, The Hague, Utrecht, and Rotterdam, with electricity and gas. Also, Friesland, we have an area where we operate only gas. And as of next year, we'll also fully operate the southwest of the Netherlands with electricity and gas. And we see a challenge emerging where this is the map of the Netherlands. If you look at the branch of the whole of the Netherlands, they published this map occasionally updated as well, and you see that many areas are turned red, orange, and yellow. Also some open areas, but you can see the coloring is getting more and more increased towards red. And this is all has to do with indeed the challenges that my predecessors, Sabine, Kai, and Gregor talked about. How do you deal with this emerging amount of DER? So new ways of collecting and producing energy, but also the electrification of electric vehicles, electric cooking, etc., etc. And if we look, and I will, if we look into our challenge and make it as operational as possible, we need to make investments in copper and in enhancing our grid from our head office, which is at the Blaak in Rotterdam, until Ankara in Turkey. So this route, which is close to 3,200 kilometers, is for us the challenge that we as a grid operator stayed in need to challenge. And this challenge also applies to our colleagues Alliander and Nexus. So imagine 10,000 kilometers of new cable to be provided in the next years to come. That's a big challenge, of course. So stop chatting about it and start working, right? Yeah, it's not that easy, because in this challenge, we also have to transform from a DNO, which is a network operator with basically placing the cables, maintaining the cables, etc., to a DSO, the system operator. And this is by law, European law, but also the Netherlands has an interpretation of that. So how do we govern also our mid-low voltage areas, but also the individual connections that we service, like residential houses or industrials? And you see here, if you look closely to my colleague, he's looking at blank screens right now. And that was the fun part of this picture. And I want to fill in those blank screens because I strongly believe that if we only invest in copper, we don't have a societal optimum for our investments, because it's a major investment in the Netherlands to do so. It's over 100 billion euros. So I strongly believe this amount of money can be less, and it can be done so by doing it smartly. And indeed, as my predecessors discussed, joining forces with our ecosystem. So how can we incorporate flexibility? How can we incorporate smart AI? So for example, in the predictability of sun, wind, but also economic predictability. So what economic triggers will trigger a battery to charge or discharge? And it's not only wind or solar. So this is a picture, and on purpose, it's quite small because it's a lot of information there. The main thing I want to emphasize here is that we are at the, I think, at the verge of digitalization of our mission critical assets as a DSO. And it all starts with gathering information, just measuring. What are we doing? We have numbers and formulas calculating our predictability in the grid, but these are based on production only. We need to be more smart about it and get the actual data from our connections, our low voltage and mid voltage range, via IoT sensoring. So smart meters, but also distribution optimization metering. But imagine the heaps and heaps of data that we collect from that. Not only having then electronical congestion, but also data congestion. So big data solutions need to be in there. Edge computing to decentralize decentral energy collection and make sure that we have like a management summary to deal with it in AI to increase our predictability. If we look at and we have that information, then we need to work at our daily operations. So we need to increase our SCADA system, also apply edge capabilities there. And then we start with a digital twin. for operational purposes. So really day-to-day, minute-to-minute operations, so that we can indeed keep the light burning and make sure that all kilowatt hours that are harvested and produced by all solar panels or wind are indeed processed through our system. And finally, we need to bring all this together in one enterprise digital twin where we can optimize our 30-year investment plan. And that's interesting because I mentioned the 100 billion euro investment that the Netherlands needs to do in its energy environment. All variables are put in place internally and externally with cities, municipalities, provinces, infrastructure, etc., to make an optimal investment portfolio for this challenge. And by doing so, I strongly believe, and my hypothesis is indeed to our board of directors, but also to the Dutch ministries, that we can do it for way less money if we do it smart. But you need to start working on this as well. Then we go to blockchain. So fast forward here because this is all interesting and whatnot, but how can blockchain help us on this? And we start with the beginning, and that is the mission critical assets I mentioned. So all sensoring, all smart meters, etc. Together with Jannes and his team from Energy Web, we work on the asset onboarding of the mission critical assets. So that's basically the top layer of the Energy Web switchboard. And that's basically the start we can do because it helps us to improve our IoT security. I think this was also mentioned by Kai. This is for us the first main trigger in our endeavors, basically on IoT. If you Google it and look for IoT risks, security is number one. And this is also acknowledged by my colleagues. Also, the installation first time right is still a big headache at Stedin. To be quite honest, we are rather bad at installing sensor equipment because it's not our day-to-day job. Our day-to-day job is installing copper and not IT systems connect to the copper, IT-OT discussion. So that needs to be improved. And by doing so, by onboarding, we are working at a installer app where the installer only needs to verify its identity, but by logging in with facial recognition or your fingerprint identifier, you're already logged in as an installer, right? So that's easy. But also, we can connect the GPS data to it. So the location also is then known. If we connect it with our geographical information system, we know what station or transformator is connected to it. Finally, the installer needs to confirm indeed that he has finalized the installation, like installing a computer program. So as easy as that, that's the aim and the ambition. I will fast forward a little bit. Data quality indeed is also important. So if we have manipulative data in our grid, yeah, we cannot work with that because that really disbenefits our prognosis, our predictability, or plays the market, games the market. And if this will happen, then we need to eliminate this faulty source, of course. So it's a bit of a hefty discussion there, how and what triggers, because it's a rather new game for us, but we want to do so, and we want to have this capability in our system. Asset registration, if we look at the heaps and several amount of assets that we have, they all require different ways of registration, and we can optimize it and uniformize that. That's critical for the total cost of ownership of having these assets. And there's one enabling part, and it's the bottom part I didn't touch yet, but it's basically interacting with prosumer assets. And by connecting our assets with the location identifier I mentioned, with prosumer assets, which also have a location identifier, we can interact and play the decentral balancing, congestion, or the power quality game that is needed to maintain our grid. How are we on time, Jannes?
Yeah, actually, we're 10 minutes ahead of schedule, so yeah, take your time.
So I will take some more time. The last slide I have for the audience, because if you look at the Energy Web switchboard I just showed you and all the capabilities that we want to enable, it's quite a heap of information and quite a heap of capabilities that we want to enable at once, right? So even myself, as the front man at Staden for realizing this, I was a bit puzzled where to start, because it's a competence that is not that we have heaps of within the DSO, but also it's quite a lot, right? That's coming towards us. So we have a 7-step approach here to a complete model, and it's just to give you and the audience a bit of a guidance where to start and how you can implement this, or how you want to interact with this, or do you have any ideas about this? I'm open to discuss. But it starts with asset onboarding. As we speak, Jannes and his team is working on the background. Jannes not himself, but his team is working on this to onboard our assets, just with a sticker, a QR code. And we can already benefit our asset registration, where we have indeed a big headache as we speak today. But if you really want to mitigate the main argument for doing so, for having indeed a blockchain as a solution, not only just an IT solution, but a blockchain solution, then we get to security. And there we are in contact with our telco supplier, and they're really open because they love the ideas and the arguments that are provided by the Energy Web team and by the Staden team to integrate this with a SIM. And the SIM allows us to optimize on multiple levels, but the main one is security. And then we go a bit faster. So the backend integration, I mentioned, the automatic provisioning for the installation process, because we need to install, I believe, up to 4 or 5, 6 million assets to monitor our entire system, from the connection level until the low voltage, until the mid voltage level. And it's quite a challenge. So we want to also extend those practices, just starting with a simple item with a sticker until a SIM card, but also all assets, but not only electrical assets, but also heat assets or gas assets. Or I had some ideas flying around that we need to, we can also track our stations. So it's not a connected asset, but also a fixed asset like the station, and the doors that we open and close, that we can track what installer has opened what door and did he close the door or not, because it's a safety issue. So you can see that although we have indeed mission critical assets and the prosumer assets, that also other use cases will form around it. That's the fun part about innovation. At the 6th step, we want to onboard the third-party assets. And I didn't touch that one quite hefty at this presentation, but I'm working on a couple of pilots I'm happy to discuss about in practice with residentials, with communities, with industrials, and their assets, 500 kilowatt battery or heat pumps, even climate systems, of course, solar PV. And they are happy to help with us and think with us, because they want to really reach another level of their business case. So of course, as Gregor mentioned, we have net metering in the Netherlands also. That's the best business case still, but we can see that this business case is declining over time. And what new levels of business case can we reach for customers? And I think onboarding third-party assets and giving them a legal entity can help the business case of all players in our ecosystem. But also, besides the monetary argument, we can indeed track the CO2 values, which is a more sustainable argument. Finally, if we are willing to do so, we can also add more data to the blockchain. So that's the security optimization. Is more, if we look ahead in time, we will know a bit more about what data needs to be stored in the blockchain off chain. And if we have information about transactions, I think we need to look into that still. But if you want to store it in the blockchain, it can be a possibility. So that's basically, in a bird's eye view, where we work on. Again, happy to speak to you about the practicals that we do behind the slides of the PowerPoint. Again, I'm looking forward to the discussion that we have from here. Thank you.
Thank you, Arjen. And with Arjen's presentation, let me thank all the panelists for setting the scene for our discussion. And we will start with the first question that will go out to Sabine, bring from Shell. So you mentioned, Sabine, in your introductory speech that Shell set up a blockchain center of expertise, which you lead. Could you tell us a little bit what is the aim of that center of expertise and why you believe it was so important to set it up?
Yeah, sure. Happy to share a bit of light on that. So, yeah, for us, the Center of Excellence does a number of things, right? What we're really tasked to do is to be deep technical experts on the technology, to have clear understanding of what this technology is and what it brings to our industry, but as well as really be clear on what kind of solutions we can build and how we can bring those to the industry. So, when we first started out the Center of Excellence, we started doing some pilots and POCs within different Shell businesses, I think around 2017 or 2016, 17. And at that time, as Shell is a large company, a global company, what is normally done is a Center of Excellence is set up to make sure that we can help all Shell businesses. So you can think of more the upstream side or new energy side, downstream side, and really help to coordinate the general agenda for blockchain across the whole Shell group. And within this space, what we pretty much do is 3 areas, right? First of all, we help all these businesses like Renewable Energy Solutions explore the value of blockchain. So we take use cases that we map out, opportunity framing strategies. We do proof of concepts, we bring in startups, we bring in different ecosystems to mature those concepts throughout our funnel. Secondly, we need to make sure that the right technology choices are being made across the Shell group, that there's some sort of alignment across both architectural standards, token standards, the way we design decentralized applications, the way we handle privacy, the way we handle the architecture overall of a full stack of decentralized applications. It's really critical for us to get that right from the start and to learn and to really carry those learnings as we develop new pilots and bring new solutions to other places. And lastly, for example, what we really key at doing is develop this kind of capability. Do we need to develop a whole developer team within our IT organization that can be purely focused on developing smart contracts in future? Or do we need to have a full set of architects that are working in external ecosystems to help devise the way Shell would interpret these kind of protocols or how we would want to design them? These kind of capability on a large scale that would come from our coordination. And most of all, just making sure that we have this awareness across the group and that we actually get to real implementations, both internally in Shell, but also externally in the energy industry. So really being the face into external consortiums or ecosystems like the Energy Web Foundation that we help to be a founding member of. Those are sort of the key items that we help to bring innovations internally in Shell, move them forward, or bring new ideas externally into the market.
Thank you, Sabine, for sharing us information about your blockchain center of expertise. Now I'll switch over to Gregor from Sun Contract. So, Gregor, since the topic of today's panel is renewable energy and how these technologies such as blockchain and AI can promote this, can you share with us a little bit more on from your expertise and from your experience with Sun Contract? How can blockchain technology actually support the green energy transition?
Thanks for the question. Yeah, let's say from our perspective, blockchain is very essential here because the customers who interact with each other, producers and consumers, they need to have trust. They can trust us or they can trust technology. Technology is always better. There's math behind. There is no personal influence. So they can trust us. Of course they do, but they don't need to. They can trust blockchain and they know that nothing can be erased in blockchain. So that's why blockchain here is a big element regarding the trust. The second one is automatization. Of course, we use smart contracts and we automized many things. We use a blockchain ledger in this case. And of course, we're bringing data and some stuff we don't need to care about. The blockchain is caring about this. And thirdly, of course, we do settlements, we do payments through blockchain, and that we do on a daily basis. So that's not possible to do, let's say, with classical bank system, but with blockchain is no problem. So I see here blockchain is a huge advantage, and because of the blockchain, we could have did a different new business model and promote a new service to the customers, and that's why this is actually advantage on the market.
Thank you. Thank you, Gregor. Yeah, my next question now goes to Kai from Elia Group. So Kai, you mentioned that you have been working on several proof of concept projects. So what is your experience working on this type of projects, and what is the vision of Elia Group on blockchain in the power sector in general? And if you can also elaborate a bit more also on a question that I have received from the audience. When do you expect to move out of this, let's say, POC phase into a more, let's say, larger scale implementation of such type of projects? Thank you.
Yeah, I think, I mean, we see already that some projects go live. I mean, like Gregor just explained that there are already solutions on, but I have to admit that for our case, we move towards MVPs. Still in the POC phases for many ideas, but I think that it's difficult for blockchain because it's a collaborative approach. So you first need to develop ideas and products, and then if you want to test them, you need to convince many stakeholders to participate, and that is quite tricky because it's a new technology. It requires a lot of explanation. Expertise is not always there, so it can be also quite difficult if you mention blockchain today. So but at the end, it's a collaborative approach, and only if everyone participates, these products will fly. And yeah, if we look back into our journey at Elia Group, so we started, I think, 4 years ago, where we really learned about what is blockchain and what does it bring to us. And it took a while until we found a use case, because it was also, we entered into many discussions. So we said, okay, transparency is also an issue. So if you put metering data on a blockchain, they are transparent, and they're for everyone, and they are for good. So you have to be very careful if you design these use cases. But what we found out then, and where we see the large benefit, is in this decentralized identification, because I mentioned it in my introduction speech. The energy system will consist of so many different assets and so many different participants that no one wants to onboard all these assets into one central platform, because then we have one platform that owns it all, that manages it all. And with this technology, we can basically put the ownership of the identity to the owner of the asset, and everyone can benefit from it, and no one owns the whole thing. So that is very promising. And yeah, and then if you have a system where participants and assets are digitalized with identity, you can also start exchanging information that then can be trusted or verified independently. So with the concept of verifiable credentials, we make claims about capabilities, technical requirements of different assets, and then every participant in that network can basically validate these data independently without an intermediary. And why is this important? It's because we look into sector coupling use cases where it's not even in one ecosystem, so it's cross ecosystem, and then this gets even more important. And we do a lot on e-mobility, because I think e-mobility is a quite an interesting use case, because the need for such decentralized identifiers will increase if we move towards autonomous vehicles. There are many use cases where these vehicles have to identify themselves to move around in the city and to use services like, I don't know, parking. There are new concepts like ride hailing, peer-to-peer car sharing. And on top of this, we can use the electric vehicle also for the energy sectors. And this is why I think that The mobility sector is very interesting for us to collaborate with, because we see that the technology arrives there already. So people, they know what we talk about, and this is also where I hope that first real use cases will be implemented and will be put in place. And yeah, maybe I can share a bit what we do, what kind of use cases. So in order to use electric vehicles for grid services, for ancillary services, for example, so to provide flexibility, we need to know what kind of asset that is. In the past, these assets were power plants, and they were connected to one grid connection point. And now these batteries, they drive around, they are connected to different charging poles at different locations in different grid areas. So we need information about who is that asset. And this can be realized by the technology that is enabled by blockchain. So what we did is we tested these pre-qualification or these authorization processes with automotives. So we created the ID client that can be installed in a vehicle, and then go through this authorization, go through this verifiable credential process to get verified data. Another thing is, and this is actually very interesting because it's really a sector coupling use cases where we think we can provide an added value also to customers, is that today, if you charge at a public charging station, you are bound to the supplier of the CPO, so the charging point operator. And if you want to make a smart system, you could also say an increase self-consumption. Why not use the electricity that you produce at home at your rooftop PV panel at public charging stations? So you could switch the supplier, so to say. So select whoever you want to charge with, but in real time. And therefore, and mobility and energy need to work together, and information need to be made available in a trusted way. And I don't believe that this will be done through one single platform, because I don't know who would manage that platform. And this is why I think that these decentralized technologies are very, very helpful to also solve that issue. We also look into green charging, so granular certificates of origin. Today, the certificate market is working on a yearly basis. So if you get a contract of a green energy supplier, they guarantee you that over the whole year, in sum, you have certificates, but they don't tell you that in the moment of consumption, you are actually using green energy. So, and with granular certificates of origin, you can solve that issue and you can increase transparency there. Yeah, but maybe to sum this up, I think that decentralized identification, verifiable credential is, from our point of view, the most promising use case right now to really create trust between stakeholders that don't know each other, to increase the availability and visibility of assets, and then to reach this higher process efficiency and new use cases where then AI also comes on top of it to optimize charging behavior, to price optimal charging, to participate in different flexibility markets or products. So yeah, that's probably it.
Thanks, Guy. As you mentioned, I think the focus right now is on the consumer assets, which are, let's say, keep growing in an exponential manner. And this brings me to the next question to Arjen. So, Arjen, the energy system will be, or I think is already governed bottom up, right? The consumer decides the investments, the timing, and so on. So, being a DSO, what is, in your opinion, the tipping point to evolve the energy system as we know it from a top down to a bottom up approach? And what will be the role of blockchain and artificial intelligence in this transition?
Good question, Jannis. I think two questions. The first one is on the tipping point. In my opinion, it's after an in-depth market analysis, we've identified that's a chicken and egg story. So the chicken and the egg are in this case the market and a bit of legislation. So the market expresses, if we don't have any certainty, if we invest €1,000 in flexible assets or decentralized assets, that we get our return on investment. Currently for residentials, the best business case is net metering. So this will decline over time, which will create asymmetry in pricing for buying and selling energy, which can create a market and then can create more clarity on pricing and business case. So that's one part. Another part is that interaction from local energy sources, even the small ones like electric vehicles, they can interact more and more via what Kai expressed, and also with what we are doing with the prosumer assets via DIDs with TSOs and DSOs, enabling a new layer of business cases, not only locally with the asymmetry of pricing, but also adding their services for imbalancing services and congestion or power quality services. So that's also interesting. So that's one. Legislation is also interesting to mention, is the translation of all European countries of the clean energy package. So how do we interpret the clean energy package, and how do we realize that? And if all countries have different interpretations, there are similarities, of course. And in the Netherlands, to be quite honest, we're still waiting to have this clean energy package implemented in the new legislation, which will enable a lot more rights and freedoms for these decentral players. So that's an interesting one. Second question was on the role of blockchain and AI. I think, yeah, without repeating my predecessors too much, it's about tailoring all individual decentral needs and activities and assets. So no central system should be or could be, in my opinion, equipped to tailor all these several assets, but also needs and demands. Because I have a different need and demand than my neighbor for using my EV, my electric vehicle, or companies have different sustainability goals and visions. How they want to interact with solar PV or wind, or indeed their certificate business. So that's also, I think, the way blockchain and AI can help to make this more easy, and that's needed. Automatically, that's also needed, because in the pilots we have tried the null hypothesis, where we say, okay, let's see if we can influence behavior of our participants. For example, if the sun is shining, put on your washing machine, or start cooking, or start your car, etc., etc. And we put a monetary bonus to that. Say, okay, if you do so, you can win 500 euros. And we track it, we display it on a user interface. And of course, people get enthusiastic at the beginning. Oh, we're doing good, we're doing sustainable actions, until the first person has a cold shower because of the heat pump didn't work properly and didn't provide the comfort because it was adjusted differently to heat the boiler at the moment of sunshine. This was this factory event by somebody who really can influence the entire group, and we saw that the energy and interaction declined after this event, being that on behavior you can have a small boost, but it needs to be automatically, it needs to be smart, it needs to be needs to cooperate with our day-to-day different schedules. And I think, and we've seen the pilots as well, that blockchain and AI can facilitate that.
Makes sense. So thank you, Arjen. So you brought up, apart from blockchain, the topic of AI, and I would like, let's say, to start the next round of questions with Kai. So Kai, apart from blockchain, let's say, ensuring the trust that is needed for a system to operate and for our TSO to manage its grid, how do you think AI can support towards a more optimal management of a transmission grid?
Yeah, I think if you look at blockchain and AI, I think the link is really to the external world, but AI is supporting us or will support the management and the operation of a digital TSO in many levels. So it's not only the market integration, where I think the very interesting link to blockchain and different sectors is relevant, but it's also system operation. So really operating the grid, dispatching it, finding the best topology. And then the third part is asset management. So yeah, find a new better approaches to maintain assets, to identify failures, but also to new image recognitions, for example. But yeah, maybe let's start with system operation. So I think what is or what brings complexity is the volatility of wind and PV. So we have large shares of renewables in the grid, and it completely changes the way how the electricity flows. So this is something that was quite stable in the past. You had recurrent patterns, and now this is becoming more and more complex. And then also the number of power plants is of course increasing. So you don't have these large power plants, but you have many small. We have new other assets like HVDC power lines, phase shift transformers, all the switchings that you can do. And that brings our dispatcher in the future into situations that are very complex. So today the decisions are taken, I would say, more or less manually. And now we need to combine all of this information that we have from sensors, from the market, from the weather, create forecasts, and then act in very short time to keep the grid stable, and so that's not leading to overloads or to voltage drops or increases. So this is why we basically right now are developing new tools where we collect different data. We use AI to feed decision tree tools to, at the first step, support our dispatchers so they get recommendations in certain situations. So it's not fully autonomous. It's supporting basically our colleagues. But that will move, of course, towards a more and more automated system. So I think this is one part. And then for the market, I guess I mentioned it already. So we have different sectors. We have heat that comes into play. So all the heat pumps, electricity to heat. We have the industry that is electrifying, and these whole number of participants and stakeholders. They need to react on price signals, but also on weather in order to optimize their operation. In order to optimize their operation and their energy consumption. So if you want to provide flexibility, you need a lot of information. You need to process them, put them into data models, and then react, decide on which market you want to offer your flexibility. And yeah, and I think also to connect many different assets. So in virtual power plants where you connect batteries into one large power plant, you again need many information. You have different assets. They maybe want to switch into be one time in this virtual power plant, maybe next 15 minutes in another one. So you have to be able to realize the switching, but also to take very good decisions in very short time. And then for asset management, yeah, so what we do is we try to use data and also sensor data to increase the ampacity, so the capacity that we can put on high voltage lines. So use weather information. For example, when the wind blows and it's cold outside, you could potentially put more electricity through the power lines. So this is one idea where we also need algorithms. Then we use drones, fully autonomous drones, so beyond visual line of sight drones that we are testing them, that fly around our transmission lines to look for failures. Image recognition that uses AI. Yeah, and then also for planning of maintenance and outage plans, I think there it becomes more and more complex because the grid is highly used and it's so volatile that it's very difficult to create outage plans. And also therefore we have to have lot of data available, process them, and take decisions. And there we also rely, or will need to rely on AI. Thanks.
Thanks, Kai, for giving us the insights on how a transmission operator can let's say, leverage and use technologies such as artificial intelligence. And let's get also the distribution system operator point of view. So, Arin, you mentioned in your introductory presentation that there is this ongoing journey of studying from being, let's say, a DNO towards becoming a DSO. So one of the first, let's say, things is installation of distribution automation equipment that will generate vast amount of data. So what do you believe is the role of AI to support the operation and the management of a distribution grid?
Yeah, I think I have quite an overlapping answer to Kai. It would be strange if we didn't have any overlap there. But I will keep it on 3 items. So on an ecosystem level, we see AI contributing to investment planning. So killing all subjectivity, all politics, all bullshit aside, we can use AI to make a more objective overview of our investments. I think that's something we can learn by and do so. The second one is on the management of energy itself. So it's more system based, where we look in how can we manage all volatility. So the 3 levels I mentioned was wind, solar, and economic volatility, where on decentral levels, these will have all their own characteristics, all their own produce or consume profiles, and these will be steered more and more and automated more and more. How can we make those how can we see those and make them predictable for us? And predictability is a key there with AI, often mentioned in the same sentence. For us, it's key to know what is coming in our grid and what is going out of our grid. And we are punished or rewarded by having the most optimal predictions towards Kai's colleagues in the Netherlands, Tenet. And we need to improve on that. And also legislation will urge us to improve on that. So that's the second one. And for the third one, it's more indeed on the asset management level. So maintenance, for example. Currently running a pilot where we do predictive maintenance on a transformer, where we look into, can we predict the out of order dates as clear as possible, instead of just having like a contractual value with a supplier saying, okay, this transformer will last 30 years. We look into several transformers, how they are being used, how also the variation is changing, and AI can predict for us the variation increase or decrease over time, and also can predict if the 30 years are indeed feasible, because if variation increases too much, then the 30 years will become an issue, and now we have costs that we need to take for changing a transformer sooner. Or we can leave transformers longer if the variation is stable, and we can keep them running for until they're like a museum prop. So that is a trade-off for predictive maintenance. So on those 3 levels, again, ecosystem level, system level, and asset management level, I see clear use cases for both internal and external use of AI. Back to you, Jan.
Thanks, Kai. Thanks, Kai. So we discussed DSO. Now I would like to shift over to Sabine and ask her, a big corporate like Shell, okay, you're not only focusing, as you mentioned in your introductory speech, only on energy, but you are looking also into other use cases like supply chain. Can you please share with us some of the ongoing or completed projects that you are currently participating in?
Yeah, sure. Happy to shed light on some of those projects and overviews that we have. I think maybe just to categorize our work into two specific areas that we do, I think there's 4 areas that we're active in different ways that you can view it. On the one hand is projects, right? How do we implement actual projects from proof of concepts to pilots to actual operations? So that's one area which I'll touch upon. Second is, of course, ecosystems, which of course is an absolute enabler for us to create impact and to jointly collaborate on network levels, but also standard levels and applications. Consortiums is another one, which I would move apart from ecosystems, which is an area we're active in. And lastly, startups. So can we invest in any new startups that we see moving into the space where we can support and we can invest in them in the early days? So those are the 4 categories of spectrums that we focus on. To start off with the first one, in terms of projects, we have a range of projects. So I explained earlier, we have 3 strategic areas that we focus on in terms of clear strategy, where in current processes that we want to improve, create new value chains and disrupt value chains, and ultimately create new markets. If we zoom into the current processes, I think, the main driver for us is to make sure we operate our plants and operate the production of energy in the most efficient way possible. That means revolutionizing the way that our industry reacts and interacts with one another, removing old processes from that area. And one of the main projects that we've been running in this side is called a concept called Project Falcon. It's a bit our code name for this. And we've been doing different concepts and pilots and implementations of this over the last 2 years with 4 key supply chain partners, so really representatives from every single part of the supply chain, where we create decentralized digital identities for pieces of equipment. And we create that as a sort of passport, like we've been talking about passports for meters, like we've been talking really to be able to participate into energy markets. We do the same for materials that start off at the origin when that piece of material is created, that gets a digital passport, and actually all data points along the supply chain as it gets manufactured, inspected, and ends up at a site of a company, that gets stored in a decentralized way within this digital passport. Now, because you're creating this open shared infrastructure, you're removing processes that have been there for decades. And I kid you not, paper-based processes across supply chains, communication with individuals between different companies, people trying to search for the latest information, the latest records. This is such a pain point for a lot of the partners that are collaborating across these supply chains. So a real clear case for us where we can say, hey, let's use digital and decentralized technologies to create a data exchange amongst multiple players and ensure that is linked to a physical product. So that is one area, and we're currently in a process of not creating this as pilots that we deploy within Shell. We're really creating industry momentum behind this and moving this into an external play. Other projects that we're focusing on is we have a wider range of concepts where we're looking at traceability of energy products. More and more, we want to be able to be assured as customers that we say, how do we actually know that the energy or electricity that you buy is actually green energy? Or how am I sure that hydrogen that is being produced actually comes from sustainable sources and not from other type of unsustainable sources? And that creates, especially in these new markets like hydrogen or biofuels market, etc., there's such an added layer of transparency needed within the whole industry to, again, create that provenance of the data of where does these energy products come from, how are they produced, how efficiently are they produced, and what kind of attributes do they have, to ultimately classify them as green hydrogen or blue hydrogen. And we see that the convergence between all these different energy sources coming together and also proving the origin of those energy sources is going to be key for the future in really creating that transparency across the supply chains. To shift maybe over, we've got a couple of more projects, but maybe to save time to shift maybe over to the ecosystems and consortiums part. The ecosystem, of course, we are a founding member of the Energy Web Chain, Energy Web Foundation with the Energy Web Chain and the components. A rich ecosystem, I believe, with many diverse players that we're part of. And we really see this as one of the most mature energy ecosystems out there that we participate and work closely with. Other consortiums and JVs that Shell's part of is in the trading space. So for example, VACT and Comgo are two names that might have been heard for a number of years already, established blockchain companies that really create a more efficient process for the trading space, so post-trade settlements. And VACT and Comgo are two separate JVs that have been set up for this in these consortiums. And lastly, I think it's really important. There's so many different startups, right, in this industry working, and for us, it's important to help them, really accelerate the development of these new solutions. So we have a Shell Ventures arm that is a VC arm, a corporate VC arm, as part of the New Energies organization, Shell. And together with them, we scout for new startups. We look at those new value propositions. And a couple of years or 2 years back, we invested in a company called LO3 Energy. This is also a company that really is there to create energy communities and participation. And here Shell is an investor in these kind of companies. So that maybe to give you a broad spectrum of the types of projects that we do. So in all, very big funnel, loads of proof of concepts, quite a number of things already in production, which I think is exciting. But I think an extra lens, which is really important for us to not underestimate, is the ecosystems, the governance, and the consortiums at play, which I always try to remind, businesses and strategies with new concepts. These are the harder parts. It's not the technology, it's that harder part. And let's make sure we bring the right individuals at the table that are really going to pioneer and help us to accelerate this kind of technology at play. So I hope that sheds a bit of light into the different types of projects and activities that we're doing.
Thanks, Sabine, for walking us through your project portfolio at Shell. And let me close this round with a question to Gregor. So, Gregor, you're running, let's say, Sun Crotang platform, which is about mainly peer-to-peer energy trading between other things. You're focusing on renewable energy, and also we heard from Kai and Arian that the variability of wind and solar production is a key challenge for renewable energy trading. So, from your experience in Sun Contract, why is AI so related to renewables?
Thanks for the question. Let's say let me show you a little bit differently. Maybe I worked also in TSO for 3 years, and DSO working with now as a partners for many years, and so we are facing different levels where mostly data is missing. When we're talking about DSO, they don't have data, or they have hardly to provide you data. And if we are talking about a blockchain solution and peer-to-peer trading, you need data that you can manage all this stuff. So we found the solutions, and here different ways. And one of those ways is also that we use AI to support missing data where this data is not provided. So in this case, AI is preparing this data for us and get the best option in this case. So because we are on the market, we are coming from the energy sector, and we see directly the regulation barriers there. We are not going from the technology part, what blockchain can enable us, but we're mostly coming what we can do within existing legislation, and that we do bring added value to the customers, and of course to support renewables. So our goal is clear. So we want to transform all our customers to come to renewables, and then it's a question how to do this. So we found different ways, and there is going to be different ways in different countries regarding the regulation barriers there are. But AI is here a key point, because our platform everything is about predictions, everything. Regarding the energy consumptions, regarding the production, renewables actually are the easiest part, but wind. Wind is not easy part, but solar is very easy part. Actually, with solar, there are AI solutions on the market. We can buy services. We can use this service, integrate services. We have APIs. It's done. It's pretty simple. It's easy to be done. So let's say hydro is a little bit more problematic because we are not talking about big rivers, but we are talking about small rivers, and the small rivers there is a lack of data, and then we have to do AI by ourselves. But then you have a production side. Consumption side. Consumption side is a huge palette of issues you have to manage, and we of course use AIs to predict what will be consumption in the end. And all then in the end you put on the blockchain, on the peer-to-peer, and then you can provide a solution for the customers and added value for the customer. So I mean, this is a kind of huge, a lot of questions in one question. But yes, AI is an essential part here in case of for prediction side, blockchain from the trust side, but a lot, both together, I can say is just 20%. The 80% is a business model and all this obligatory stuff we have to do that customers can be connected, they can be converted, and let's say not just one customer or one household or industry customers or business customers, but we, let's say, convert whole villages or whole towns to be self-sufficient. And this is all supported on Sun Contract platform, and it's all supported by AI and blockchain. So we do this in real. So we opened, let's say, first self-sufficient village in August. Now, October 1st, we do first city center to be self-sufficient, and everything is supporting on the peer-to-peer and of course AI behind. So that's a lot of what we can talk this about maybe for a day, but yeah, those we combine this together is one aim to prepare a new business model and a new solution that we can convert customers to renewables for 100%.
Thanks, Gregor, for sharing your experience through Sun Contract. So let's open up the discussion to the panel. Yeah, we received, as you saw, questions from the audience asking when these projects will move out of the POC MVP phase and move towards production. So I think one of the key questions to be answered here is, what are the challenges and the prerequisites for AI and blockchain use cases in the energy sector? So we have adoption from the industry, adoption from the community, and also, is it, let's say, a technology issue, or is it more an issue related to the current regulatory and let's say legislation frameworks across Europe? So let's start with Arjen. Arjen, what's your view on the topic?
It's twofold, Yannis. I think that the first one is on clear urgency you can feel yourself in your own household or your own company. And companies are more advanced in that than maybe households. But what I see now currently is that with the map I show with all the red, orange, and yellow areas, is that once that really hits you in for example, housing, you cannot, for some cases, you cannot build or connect new households or new connections. That's something you can really feel. But this level of urgency is, I think we're at the verge of that in the Netherlands. So it will come and it will push boundaries legislation-wise, but also market-wise. It will open gates for the market to really come and come up with a repetitive business case. That's the second one, the repetitive business case. So currently, clearly expressed by everybody, we are all in MVPs and POCs and pilots or whatnot. And most of those, I think, I assume almost all of them depend on subsidiaries. So if you look at the current business case, it's all subsidiary driven. But we need to come with a self-sustaining, maybe without subsidiaries, business case that is repetitive. And I understand it's a stacked business case. It's not only just one level which you need to unlock, and then you have you go from red to black business case basically. But I think there are service suppliers that can combine several layers of monetary value or sustainable and monetary value and provide them to the market. But they currently cannot provide the market with a repetitive business case in the Netherlands. And I think then you come with the urgency. The urgency will eliminate legislation boundaries and go from. And also urgency is more on currently still an opportunity to unlock with AI and flexibility, etc. And we need to go from risk mitigation to prevent that we cannot connect houses or we cannot provide all renewables in our grid. So that's basically my view on how we can go from a POC level to a more scalable level.
Yeah, also just to share my view on this one, and then I will shift over to Kai. Yeah, Kai, also you mentioned like you're exploring how small scale DERs like EVs, right, can participate in flexibility markets. You're dealing with the issue from a TSO perspective, but we all see that there is a need for small scale DERs to participate in the markets. In some cases, why not directly without the need of an aggregator? I was reading yesterday some comments regarding the plan, the roadmap of the energy digitalization, energy transition of the European Commission. Some comments compiled from GOD, EDSO, ENSOE, and SEDEC, and they are focusing upon what we stated at the beginning, that there is a need for any asset to participate in any market. So from my experience, currently there is no regulatory framework in place that can support this. In some cases, we're working inside sandboxes and siloed environments, but do you foresee that in the near future we will have such sort of freedom to move into a more commercial deployment of such solutions with the support of the regulatory authorities and the legislation as well? Or is it something that we need to see through the telescope?
I hope not. I think, I don't know, I can give maybe some practical insights where it's quite difficult today to release small scale flexibility. That is also because how the energy system works, because even your household is planned with standard load profiles. So even if you would adapt to flexibility signals, you need an active balancing. So you need to know how much you consume, and that has to be reflected in the planning of the balancing area operators. So there are things that have to happen in order to reflect it correctly in the energy system. So it's not just about, okay, new roles and new technology, but there's a whole bunch of processes that are very, very complex, therefore long time, that require also a sufficient level of safety. So even if we say we use, I mean, especially for grid services, ancillary services, we have to have a level of trust, because at the end it's our electricity system, and we cannot play around with data that we cannot trust or measurement devices that aren't correct. So it's kind of a combination of how the energy system works, hardware that has to be installed, and then to make this data available to everyone and to new services. So I think that's probably the challenge. And then of course regulation has to adapt, but it's not only one issue. And that's probably my answer. You're muted, Jonas.
Thanks. I was trying to avoid this, but it happened. So Sabine, moving over to you, same question. So from your experience in working with consortia and ecosystems, where do you see the barriers for a wider adoption of technologies based on blockchain and AI?
Oh, barriers. We've seen, of course, many in these kind of collaborations, which also makes it fun, right? Bringing all these companies together, different bodies, opposing views. It's an interesting space to be in. So, from my perspective, I think, if you look a couple of years back, I think there we were at a time when just the word blockchain already got many people around a table and saying, yes, let's do it, without actually looking at what is the proposition? How do we do this together? How do we actually work together? So I think that's maybe, 5 years ago or something, where companies in general in the market were very interested just to sit around the table and talk about this. And I'm glad to see that actually throughout the years, there's a lot more level of maturity and understanding across the industry where people get the grasp of, hey, how do we do this? What is the governance required? How do we think about open ecosystems? How do we think about open collaboration at different standards? So, you know, to me, I always like to sort of think about 5 areas, which aren't per se even just, let's say, pure technology focused, but pretty much just about how do you bring companies together around blockchain use cases and actually bringing this from idea to concept. You know, for me, it's about the value, first of all, the problem you're solving and how that value is distributed across an industry. I think that is absolutely key, where you see different players coming together at different parts of a value chain. It can be a big problem in an industry that you want to solve together. But you need to be very clear upfront to the people and the companies coming to sit on the table about what you expect to see as the value distribution across that network and of these participants, what you require from them in terms of participation, and also what the potential impact can be to their companies when you really want to implement this at large scale. So I think that's really one of the key ones that I normally see. The second one is then standards. Without standards, I don't think you're anywhere. Token standards for quantifying things, and I think, you know, not all standards have to be defined upfront in too many granular levels, but you should be able to learn by building and practicing. You should be able to develop those standards in an open, transparent way with industry bodies that have that industry expertise on that front. Another one for me is governance. I think this is something that the whole industry can get better in. You know, your network layer governance, those kind of areas. We need to learn about this network layer governance. What is the ideal setup? But also potentially your application layer governance, right? I foresee that networks, public open infrastructure is going to be the future. No private permission setups are going to last till the end of day, I believe. That net governance across that public network, how is that achieved? Who has oversight? But then on top of that, your application governance, the ones that interact with one another, transact, that value distribution. So to me, I think those will be the prerequisites to really get the people around the table, the companies around the table, to get the problem that you're solving, the value distribution within such a problem you're solving, and get people in with open eyes to not only take part as tourists, but really take part into this collaborative effort to change that industry.
Thanks, Sabine. And last but not least, Gregor, you mentioned you already have deployed a Sun contract in communities. You are looking forward, expanding this into the city environment. What were the challenges that you faced during this road to success?
We are actually looking from the market side and see what actually customers are needed. So when the customers are asking us, can you support, let's say, self-sufficient communities on the village side, on the city side, we said yes. Let's see how we can do this. We saw the legislation and we said, yeah, we can do this. We have a digital platform with blockchain-based platform. We can adapt this new regulation very fast. I can tell you that regulation came into power in August 8th, and the first village was converted and put on the Sun contract platform on August 26th. So we are small, we are fast, and we are flexible because we are digital. And that's why this is actually our advantage, because utilities in Slovenia, they're asking how we can do this or what we can do this. They will need, let's say, half of the year, 1 year to do this. We did it in 1 month. So that's the way. There are challenges, but mostly they are legal challenges. How you can do this according to the existing legislation, because you have to be compliant with the existing legislation. If you are coming from the market, let's say what you talked also before, what we can do on the let's say the TSO level or DSO level, that's mostly not our, let's say, we cannot do anything about that. Regarding TSO, ENTSO-E will decide how to connect all TSOs around Europe, and they do standardization. They go this way, but I mean, this is leverage. You cannot change European energy system to go to blockchain in a year, because there is a huge leverage behind, and we need the stability of the system. And they are going step by step, but they will do this according to their way. Let's say how distribution systems, the distribution companies are doing according to the law. They get a lot of laws now. You know, the European legislation is coming back to the national legislations, and this, let's say in Slovenia now 2 laws we have implemented, and there still 4 are here waiting to be implemented. So, and one of those is, let's say, also regarding flexibility. Flexibility is a big issue, and there's going to be a bit need for that, but still, what the DSO can do, nothing yet. So they have to wait law, and they will have implemented and so on. What we can do, we can be much faster. So we are here, we have a platform, we adapt, we see which way you're going, and mostly we don't need to adapt a lot, because our design of the platform was done according to the law, which was actually implemented in European Union level on 2018. So this is already there. We did it in that way, and now this is coming to the national legislation. We are prepared for that. So that's why we can be fast, we can be very, very effective, and we are on the market, and we do concrete stuff. So we go with customers, we actually convert customers, actually bring customers, and actually bring them added value, lower energy prices. Let's say they save 15%. If they come to let's say this energy community, or if they even give some rooftops for that, they can save even 50%. So that's a new business model, and actually we don't have competition right now in Slovenian market.
Thanks, Gregor. So we have 9 more minutes until we wrap up the panel. So a final question from my end, a short question and a short response from your end. So yeah, let's say predictions. We all know that predictions are really, really difficult, especially when they are focusing upon the future, right? So I will ask for your prediction in 10 years' time from now. Will, let's say, blockchain and AI be on your calendar as part of a meeting or in a report? Or there will be, let's say, replaced by some other technology that will, let's say, disrupt the way we're doing business? Let's start with Arjen.
On this topic, I hope not, because that means that I have 10 more years of innovation ahead of me on blockchain, and that if it takes this long, then we need to also look into how do we invest our societal money in our innovations. So I hope that in these use cases of blockchain for decentral energy management, that we're already on a scalable way so that the business can take over. And I'm from the innovation department, and I can do new cool stuff. For other use cases, I hope so, because I think what makes blockchain valuable is its use case, and that with introducing the DIDs, the decentral identifiers, we can look into new use cases and look how we can make it a more social and also societal sustainable environment for our customers. So that's my short and simple answer.
Thanks, Arjen. Kai, what's your view on the topic?
Yeah, I hope that there will be some MVPs, some products very soon, and that this technology is maybe moving in the background, and that we don't talk about blockchains specifically, and that it's just there, and that it's replacing other technology. At the same time, I know that this will be a challenge, because at the end, especially when you start with projects, you could do this easier with a centralized solution in most cases. So let's hope that we jump over and find a case and demonstrate that it's really beneficial. And but I think that's still a lot of education and yeah, testing and proving of technology is required.
Thanks, Kai. Sabine?
Yeah, hard to share an opposing view. I would say for me personally, to have it on an agenda point or a meeting, it shouldn't be there. There, I must completely agree with Arjen. I really hope that by the time we have blockchains and shared digital infrastructure that we then refer to, that it's embedded, that is a given, that we're not talking about it on an innovation agenda anymore, but that we have that as a trusted, transparent layer. But I would agree that I don't think that the next computational wave, the innovation wave, I think there's going to be elements of this decentralized structure that is going to spin off all these kind of new ideas, like we're now seeing NFTs, DeFi, etc. I think there's going to be a long list. So I hope that's still on my calendar and agenda, that the base layer of neutral blockchain infrastructure is completely embedded.
Thanks, Sabine. And I left Gregor for the last one, since I would like to see some live video from Ljubljana. So, Gregor?
My opinion is that blockchain and AI will be part of the services we will face in the future. Maybe we will not talk about AI and blockchain itself, but it will be, let's say, a major part of the services, energy services we will face, because everything is about predictions, everything is about decentralization, and this all needs those technologies behind. And we know that everything is also about prosumers, so to enable customers to be producers and consumers. And this is getting a lot of diversity, a lot of flexibility to the system and the renewables itself. So I think those technology will be an essential part of the new energy services in the future, but we will not, let's say, exposed, but will be part of the services which will be more advanced than we have now.
Thanks, Gregor. And with that, I would like to thank you all for accepting the invitation and for participating in this fruitful discussion. So thank you once more, and the floor is back to Ljubljana.